Welcome to my presentation, Beyond Shadow IT, Designing an Enterprise Software Catalog for Organizational Change. This presentation is my final capstone for this independent study, where I took a real-world organizational scenario as the basis for designing a new system. In this talk, I'll explain why the main challenge in this project was not building a better software system. The larger challenge was changing organizational behavior. I'll walk through the system problem and organizational context, covering the resistance patterns found, the requirements process, design models, and finally, the rollout strategy. To start, I want to explain why this problem is really about people, not just technology. When people hear that an organization needs a new software catalog, their first reaction is usually to treat it as a technological issue. Is it really a problem with technology? We might assume that the database is incomplete, that the records are outdated, or that nobody has a reliable list of approved software. From that point of view, the answer seems simple. Let's just build a better system. Yeah, everyone, let's get together, let's build it, right? But that explanation is way too shallow. The Enterprise Software Catalog is a change management intervention as much as it is a software system. Every design decision was a response to a documented organizational behavior. Let's dive in and let's see how this really applied. The organization in this project is a federal contractor that supports the U.S. Department of Energy. They provide critical support services across several operational areas and manages a large portfolio of business applications. Its technology environment uses ServiceNow for information technology service management, Microsoft 365 for productivity tools, and a .NET and C# development stack hosted on Windows Server. Because the organization operates in a federal compliance environment, all cloud-based solutions must be certified through FedRAMP. If you're not familiar with FedRAMP, it stands for Federal Risk and Authorization Management Program. At the time of this study, the organization managed more than 24 business applications across areas such as DevOps, GIS, so Geographic Information Systems, Business Intelligence, so BI, Collaboration, PM, Project Management, and Document Management. I was examining 24 applications for this software design. However, their portfolio is very robust, and it's also maintained with a ServiceNow Configuration Management Database, their CMDB, which was intended to serve as the official source of truth for information technology assets and application information. But there are some issues we need to discuss. So, those issues. Even with a formal structure in place, 47% of software applications being served were not managed through the IT department. Employees were using tools that the IT department did not know about. Managers were approving local purchases outside of formal purchasing processes. Information technology staff members were even keeping their own spreadsheet list because they did not trust the official configuration database, the ServiceNow CMDB. But why? Why such a gap? What this meant was this was not a technological gap. It was a behavior problem inside of this organization, leading to an approximate $340,000 of annual licensing waste from untracked software. Research backed by Silicon Back describes the pattern as shadow IT. In simple terms, that means people are using software or even services outside of the formal control of the information technology department. Their research shows that this usually does not happen because employees are trying to break the rules. They're not trying to get in trouble. It happens because the official process feels too slow, too unclear, or too frustrating. Fadden and colleagues make that point even more clearly. They explain shadow IT technology as a workaround behavior. In other words, People create workarounds when the official system does not meet a real need. Using Lewin's change model, we can say that this organization has become stuck in a workaround habit. Before a new system can be succeeded or can be designed or even built, those habits have to be broken first. So the first step was not just identifying missing software. The first step was understanding what people were resisting and why. So now you should understand that shadow IT is not rule breaking. It's a workaround behavior. Before diagnosing the resistance patterns, it's worth being precise. So a little redundancy is necessary. So Silicon Back are clear on this point that shadow information technology is not employees acting badly. It's employees acting rationally when the official process is too slow, too opaque, or too costly. That reframing matters because it changes how you design the solution, which is pivotal before we dive into the software design implementation that I was working on. If you treat it as a compliance problem, you add more rules. Interesting. If you treat it as a behavior problem, you redesign the system. So let's see how this applies with this independent study. During the first milestone, three clear patterns of resistance appeared in stakeholder interviews and joint application development sessions. First, employees were installing unapproved software so they would not have to wait through very long and friction-full purchasing and approval processes. Second, department managers were approving local software purchases because they wanted to keep control over their own decisions. So they wanted to maintain a level of autonomy that they wouldn't have using formal processes. Third, information technology staff were keeping separate spreadsheet inventories because they did not trust the accuracy of the central configuration database, the CMDB. It's just as Moody and colleagues stated in 2018 in the MIS Quarterly. Employees bypass mandated systems when the cost of compliance exceeds the perceived benefit of that exact compliance. This slide is very word heavy, but just stick with me here. These are not random problems. They line up closely with the causes of resistance described by Cotter and Schlesinger. Their research identified several common reasons why people resist change. These reasons include self-interest, lack of trust, different views of the problem, and low tolerance for disruption. That is exactly what we're seeing here. We have to understand that with each documented root cause, there's a solution that we can propose, right? And that's what we're trying to do here. We're trying to solve a problem. So let's go deeper. Let's examine the three cards on the screen. What this diagram is showing is that resistance to change is not random, like we've been discussing so far. It has a specific and noble cause. And if we utilize the Cotter and Schlislinger's framework that they give us, we can use their vocabulary and name those causes. The first card is employees installing unapproved software. This looks like a rule-breaking problem, but the root cause is procurement speed. The official process was too slow, so employees created a workaround, which is natural to human instinct. Cotter and Schlinger call this hierarchical self-interest, people protecting their ability to get work done. The second card is the managers approving local purchases. Again, this looks like a compliance failure, but the root cause is autonomy. Managers do not want to lose control over the department's decisions. Same classification, hierarchical self-interest, but a different motivation. The third card is IT staff, keeping parallel spreadsheets. This one is different. The root cause is not self-interest. It is a different assessment of the situation. IT staff looked at the official configuration database and concluded it could not be trusted, so they built their own alternative. Why does this matter? Because the classification tells you what the solution has to do. You cannot solve a self-interest problem the same way you solve a trust problem. Cotter and Schlinger's point is that the response has to match the cause, and that is exactly what the system design tried to do. Looking at the table. So, the table on this slide consolidates what the cards on the previous slide showed, but it adds something new. Look at the fourth row. Beyond the three individual patterns, all three groups share a common thread. The official process felt more costly than the workaround. So Cotter and Schlingers classified that as a low tolerance for change. But Nam and colleagues gives us a sharper explanation: burden. Physical and mental burden is what turns a frustration into a habit. Moody and colleagues found the same result in a security compliance research. When following the official process feels expensive or difficult, people are less likely to follow it, even when they know they should. Kim and colleagues reinforced this further. Resistance to system change is not random. It comes from clear, measurable factors that organizations can actually address. This is what the table is saying. These are not attitude problems, they are design problems. And if we know the cause, we can design the response. Once we understand those causes, they shaped how requirements were gathered for the new system. Most requirements processes ask, what does the system need to do? This project had to ask a different question entirely. What does the organization need to stop doing first? What is that? Well, Lewin's model helps us define this. They need to unfreeze, change, and refreeze. Before new behavior can take hold, the old behavior has to be disrupted. And that is not a technological task. Technology can't solve that. It is a change management task. Treating requirements gathering as part of that disruption changed how every interview and every JAD session was structured. Let me show you how Lewin's 3 steps maps directly to the milestones of this project. So, the diagram on this slide maps Lewin's 3 steps directly to the milestones of this project. This is not a loose analogy. This is an actual structure of the work that was completed. Milestone 1 was a part of the unfreeze phase. The feasibility analysis, the stakeholder interviews, and even the shadow IT documentation, all of it was about disrupting the assumption that the current employees had about the situation being acceptable. You cannot move people toward a new system if they do not first recognize that the old behavior is an actual problem. Milestone 2 and milestone 3 were about change phase, or a part of the change phase. The requirements, the use case diagram, and the class diagram with the state machines and the wireframe mockups, they're all a part of the intervention, not just deliverables. Deployment and conversion strategy were a part of the refreeze phase. Lewin's point is that change does not stick on its own. New behavior has to be institutionalized. It has to be made into the default before the old habits come back. That is what the phased rollout is designed to accomplish. So there was a lot of thought in this process and a lot of deliverables that were just way more than just a piece of paper. But the requirements process itself had to be designed carefully. Because of who you involve in gathering requirements determines whether people trust what gets built. Cotter and Schistlinger's participation principle has 2 parts that are easy to miss. Involving resistors in the design process does not just reduce resistance, it also improves the solution. Both things happen at the exact same time. That is why during the joint application development sessions, we brought together people from IT, procurement, compliance, and even end user groups. Each group represented a different resistance pattern. We remember that IT staff distrusted official records, while managers wanted to protect departmental autonomy and employees wanted a faster process. Well, all of them were in the room, not as obstacles, but as contributors. We were collaborating using teamwork. The result in that is that the requirements came out of those sessions were not just technically accurate, they were actually politically credible. The people most likely to resist the system had already shaped it. The use case diagram on the next slide is an actual direct output of that process. Let's examine the use case diagram. Three actors groups were included: business users, catalog admin, and app owners across 11 use cases. That breadth was not scope creep. It was very deliberate. It was a deliberate buy-in strategy. Business users can browse, search, request access, and track their request status. Catalog admins can manage their content, monitor their synchronization, and even manage categories, while app owners can maintain their application records and respond to access requests. Each group has a role. Each group has a reason to engage with the system. That matters because Oreg's research is clear. People do not all resist for the same reason. Some like disruption. Some dislike disruption, right? But some really dislike disruption to routines. Some feel anxiety from it. Some are skeptical in a more rational way. A requirements process that only involved IT would have produced a technically accurate diagram, but with no political credibility. Bringing all three groups in, it meant catching different forms of resistance early before they became obstacles during deployment. Shu and colleagues support this. Their study of government agencies found that organizational support during the process shaped user satisfaction with the final system. The diagram on the screen is evidence that the process was designed to build that support. Those requirements did not just shape the features, they shaped the system design itself. The requirements did not just define what the system needed to do, they defined what the system needed to fix. Every class in the design diagram you are about to see corresponds to a specific resistance pattern identified in milestone 1. Davis's technology acceptance model gives us the vocabulary. Usefulness and ease of use are not design goals. They are mechanisms for reducing resistance. Now, here's the full class diagram. The full design class diagram for milestone 3 included 11 classes exactly. But rather than walk through every class, let's focus on 3 highlighted on the right, because each one is a direct architectural response to a resistance pattern we identified in milestone 1. Starting with RoutingChannel, it addresses the employee pattern. The system supports 4 approval processes, or paths, so that low-risk requests move through a low-friction process. One approval path for every request would recreate the bottleneck that pushed employees toward shadow IT in the first place. Now, sync log addresses the IT staff pattern. Every synchronization event between the CMDB and the catalog is logged with a status, record count, and even error details. You cannot tell people to trust the system. You have to show them what it is actually doing to build the trust. Now, access requests addresses the black box anxiety that cut across 3 groups. Request status is visible at every stage. No submitting and waiting in silence. These are not convenience features. They are resistance mitigation features written in UML. Now, let's zoom in into RoutingChannel first. The zoom in view shows the routing channel class and its 4 channels: RAMs for self-service, low conflict web applications, intake for manager approved requests, service desk for IT review of desktop applications, and a compliance escalation plan, a path for higher risk tools. That structure matters because one approval path for every request will recreate the bottleneck that push employees towards the shadow IT, like we previously mentioned. If someone needs a free, low-risk browser tool, routing that through a full compliance review adds friction with no benefits. The person waits, gets frustrated, and then finds that workaround. So Cotter and Schsinger's principle applies directly here. The response to resistance should match the cause. So employees bypassing the system because of procurement was too slow, right? So they're trying to bypass it. Procurement is way too slow. So the answer is not to mandate compliance harder. It's not. It is to design a faster path for requests that do not need a slow one. Low risk gets low friction. High risk gets appropriate review. This is a logic encoded in the classes. Now, let's look at the sync log class, which addresses a different resistance pattern entirely. Zooming into the sync log class attributes: log ID, timestamp, status, records updated, error count, and error details. Each one of those fields is an answer to a question that IT staff previously could not get from the official system. When did the sync run? Timestamp. Did it succeed? Status. How many records were affected? Records updated. Were there any errors? Error count. What specifically went wrong? Error details. The last one matters most, those error details. A system that tells you something failed is not much better than one that says nothing. Error details gives administrators enough information to act, not just know that a problem exists. The class exists because resistance pattern 3 was distrust of official records. IT staff kept parallel spreadsheets because the CMDB gave them no visibility into its own reliability. You cannot tell people to trust a system, right? We said this. You have to show them what it's doing. Chatterjee and colleagues support this directly. Visibility inside a system supports better judgment and more confident decision making. The sync log schema is that the visibility made structural. Both of these design decisions connect to a broader theoretical model, one that predicts exactly why they should work. So we talked about Davis's technology acceptance model, right? But let's actually look at a diagram that represents it really well. Let's visualize this. So this model has two inputs on the left: perceived usefulness and perceived ease of use. They both flow into a behavioral intention, which drives adoption. What makes this relevant here is that the classes we just examined map directly onto those two inputs. SyncLog targets perceived usefulness. When IT staff can see exactly what the system is doing, every sync event, every error, every record count, the system becomes demonstrably more useful than the parallel spreadsheets they were keeping. Now, RoutingChannel targets perceived ease of use. 4 paths matched to request complexity means that system feels proportionate. Low requests or low risk requests do not feel like bureaucracy. So the design is not technical, it is psychological. Every class is meant to reduce burden, reduce uncertainty, and make the system feel more trustworthy. And the TAM model tells us that those are exactly the two levers that drive adoption. Kim and colleagues confirmed this. Resistance goes down when a new system clearly feels better than the old one. The class diagram is the evidence that we designed for that outcome. That same resistance mitigation logic moves from structure into behavior, and that is what the state machine diagrams show. Coming next. The quote on the screen from Nam, Hu, and Moody is the design principle for everything we're about to see. Reducing burden is more effective than mandating compliance. That is not an abstract idea. It is an instruction for how to build the system. The class diagram showed us that structural response to resistance. The state machine diagrams show the behavioral response, where the class diagram answers the question of what the system contains. The state machines answer the question of how the system behaves when people use it. Each statement and each transition was designed with a specific friction point in mind. What happens when people start a request that is not ready to commit? What happens when a synchronization fails? What happens when an admin needs to suppress an entry without deleting it permanently? The answers to those questions are encoded directly into the diagrams. This is where change management meets UML, not as a metaphor, but as a design method. Let's look at the two state machines. The access request state machine on this slide maps full lifecycle of a request: draft, submitted, routed, pending, then one of the three terminal states: approved, denied, or canceled. Let's examine what each design decision is doing. The draft state means a user can begin a request, save it, and come back later. This is very useful. There is no immediate commitment required. That directly reduces the mental burden of starting the process. The cancellation path gives users a clear exit at any stage. Oreg's research found that emotional reaction is a component of resistance. When people feel trapped in a process, anxiety goes up. An explicit exit reduces that pressure. Routing transparency means the request status is visible throughout every stage. That black box anxiety that came from the old email and wait process, not knowing where a request stood or who had it, is eliminated by design. The terminal states are deliberate as well. Approved, denied, and canceled. Three clear outcomes, no ambiguous endings. People know exactly where they stand at every stage of the process. Each one of these is a response to a documented friction point from the requirements phase. Let's zoom in to the draft state because that single decision carries the most weight. The zoom shows the first transition in the entire request lifecycle. The user clicks request access and the system moves to draft. That is the only thing that happens. No form submission, no commitment, no point of return. This is very intentional. That single design decision was deliberate. In every early review, it became clear that people were more likely to abandon the process if the first click felt irreversible. The draft state removes that pressure. You can start, save, and come back. The system holds your place. Noam and colleagues are directly on this point. Reducing mental burden is the primary predictor of resistance reduction. An irreversible first step creates cognitive pressure. A draft option dissolves it because it was built. Well, a draft option dissolves it before it's built. That's what I meant. The cancellation path works on the same principle. Oreg found that emotional reaction is a measurable component of resistance. When a process feels trapping, anxiety increases. Giving users a visible escape at every stage keeps the system from feeling like a one-way door. Now, let's move to the application lifecycle stage machine. Very exciting stuff, where the same logic applies to the system behavior rather than user behavior. Application lifecycle state machine tracks how an application record or application record moves through the catalog. Draft, then active with paths to hidden, archived, or pending sync. Let's examine the design decisions on the right. The pending sync state makes synchronization a visible and named event. In the old system, the CMDB updates happened in the background with no indicator at all, and what was changing or whether it succeeded, we didn't even know. Here, sync is a state, something that the administrator can see and even track. The sync failure path is where the transparency principle becomes more concrete. If synchronization fails, the error is logged to sync log. The admin is notified and no data is silently discarded. Awesome, right? The system does not hide the problem. The hidden state gives administrators a reversible option. An entry can be suppressed without being permanently deleted. That matters because it removes the anxiety of making a reversible mistake. The same principle behind the draft state in the request access lifecycle. All four decision points to the same design goal: transparency over silence. System failure surfaces visibly, and that visibility is what builds trust over time. Let's zoom into the pending state because that is where the trust mechanism actually lives. The zoom shows the pending sync state and what happens when sync fails. The record does not disappear. It does not silently update with corrupted data. It reverts to its last good state and the error surfaces in sync log with enough detail for administrators to act. This is very useful. That two-part response, revert and surface, is the architectural answer to resistance pattern 3. IT staff kept parallel spreadsheets because they did not trust what the official system was doing behind the scenes. Well, this fixes it. This design removes the behind the scenes. Every failure is visible, named, and logged. Chatterjee and colleagues explain why this matters at the organizational level. Implementation efforts often fail when different stakeholders develop conflicting mental models of what the system is doing. One person believes the sync succeeded, another assumes it failed. No one knows for certain. That ambiguity erodes trust faster than a visible error ever would. Clear, visible states prevent that confusion. When the system shows you exactly what went wrong and when, everyone is working from the same understanding. That same goal, reducing friction and building trust, carries directly into the user interface design that we will discuss next. First, let's discuss something. Every design decision we have examined, the routing channels, the sync log, the draft state, was built for people who already work inside the system. The user interface is very different. It is the first thing a user encounters, and it is the only thing most users will ever see. Davis is very direct. Perceived ease of use is an independent predictor of adoption, not a contributing factor, an independent predictor. Let's remember that. If the catalog requires less effort than emailing IT and waiting, people will use the catalog. If it does not, though, they will not use it, regardless of how well designed the backend is. The UI is not decoration. It is a primary resistance mitigation for the end user. Let's look at the wireframe mockup and examine how that principle was applied. So, I did mention wireframe. It's more of a mockup, right? The mockup on this slide is the TAM made visible. Let's examine each design decision and its doing. The search bar is the first thing a user sees, not a login prompt, not a form, not a menu to navigate. Search. That is a deliberate choice. Perceived ease of use is engineered from the home screen before the user has clicked anything. The category grid below serves a different user, someone who does not know what to search for can actually browse by domain. They can use DevOps, collaboration, project management, any of those keywords. 2 entry points, 1 homepage, no dead ends. The self-service model replaces the old workflow entirely. Instead of emailing IT and waiting, a user searches, finds the tool, and submits a request in one place. That removes the primary friction source that drove the workaround behavior. Accessibility is also a design decision here, not a compliance checkbox. Section 508 and WCAG 2.1AA compliance means the system is built for a wider range of users. Shu and colleagues found that usability shapes satisfaction with organizational systems. And at a federal contractor, accessibility is adoption. Nam and colleagues add that reduced burden and mobility drive acceptance. A system that anyone can use without friction is one that more people will actually use. And that's what we want. We want to design something people use. So let's zoom into the search bar because that single element carries the most weight. Zooming in to the search bar and the top navigation stripped down to its essential form. Large, prominent, no login required before browsing, no form before you can explore. You can log in if you want. We made sure to maintain that search bar clearly next to the notifications. And that's very important. It's very hard to see because of the lack of contrast right now of the picture. However, in an actual real live demo, it's very visible, it's very easy to spot. And we have messages to direct the user to it. There's a good demoing with that. So the caption on this slide calls the search bar the system's primary TAM intervention, and that is precise. This single element is where perceived ease of use either succeeds or fails. If a user lands on this page and immediately knows what to do, the system has already outperformed the old workaround. Compared to the process it replaces, open email, write a request to IT, wait, follow up, wait again, receive a decision days later. That process had no search bar. It had no status visibility. It required effort at every step with no feedback in between. Davis's prediction is clear. When the official system is easier than the workaround behavioral, intention shifts. This search bar is where that shift happens. The final piece is the conversion strategy, the plan for moving the organization from the old habits to the new system. Let's go over that. Building the system is only part of the problem. The harder part is what Lewin called the refreeze, replacing years of workaround habits with a new default behavior. The conversion strategy from milestone 3 is not a technical deployment plan. It is Cotter and Schlinger's change management framework translated into system design language. Every element of the rollout, the pilot group, the training, the feedback loops, the phase timeline maps directly to the form. So the conversion strategy is Cotter's change plan written in system design language. Every element in section 6 from milestone 3 maps to one of the 4 documented integration strategies. So that distinction really matters. A deployment plan asks, how do we install the system? A change management plan asks, how do we change what people do? This strategy was designed to answer the second question. Let me walk through this exactly and how the mapping works. Let's examine the table, right? It makes the mapping explicit. We have 4 rows, 4 strategies, 4 implementations. Very important. Let's go over this. Education and communication appear through role-based training, town halls, frequently asked question materials, and structured announcements during each rollout phase. The goal is that no one encounters a system for the first time without context. This is very important. Participation and involvement appear through the pilot group. Early users are not just testers finding bugs. They become change champions who can answer a colleague's question from experience rather than from a training document. The peer credibility is harder to manufacture and more effective than any official communication strategy. Facilitation and support appear through the phase help desk coverage and feedback channels. Each phase has dedicated resources that problems surface quickly and do not calcify into resistance. Negotiation appears in the approval structure itself. Departments that need decision-making flexibility still have it through the tiered routing channels that we discussed earlier, but with a formal structure that the organization controls. Autonomy is still preserved, and shadow IT is not. That is very important. Rothenberger and Streit found that phased rollout consistently outperforms the Big Bang deployment for enterprise system adoption. The table explains why. Each phase gives the change management strategy time to take hold before the next arrives. Very vital, very critical. The 3-phase timeline shows exactly how that plays out. 3-phase rollout, the diagram, right? It's going to be 3 phases across 12 weeks. Each phase is doing something different from a change management perspective. Not just deploying to more people, but building the conditions for the next phase to succeed. So we have the prerequisites, right? And it's very important. Phase one is weeks 1 and 2, the pilot group. This phase has two jobs: finding technical problems before they reach the full organization, and creating the change champions we discussed in the previous slide. The pilot group is small enough to manage closely and large enough to generate credible peer experience. Phase two is weeks 3 through 6, department rollout across 5 departments with dedicated liaisons. At this point, the system has been validated by real users. The change champions from phase one are already available to answer questions from colleagues, which is very helpful. Phase three in weeks 7 through 12, organizational wide change. Lewin's refreeze. The goal at this stage is not simply to give everyone access. It's not. The goal is to make the catalog the default behavior and shadow IT the exception. So, Chatterjee and colleagues add a risk management reason for this structure. Complex stakeholder relationships can derail adoption if they are not managed in stages. Rolling out phases keeps that complexity contained at each step. So that's what we're trying to do here. We're trying to mitigate that. Let me close with the main lessons from this project. I'd like to take this moment to sum up the project in 3 lines. Right? We have the gap, the method, what's next. So the gap, shadow IT was a behavior problem, not a technology problem. Remember that 47% of software outside of IT control? That was not a database failure. It was an organizational signal. It was signaling that an official process has stopped working for the people it was supposed to serve. The method. Every artifact is a change management instrument. The feasibility analysis diagnosed the frozen state, while use case diagram built political credibility through inclusion. Class diagram encoded trust and transparency into the schema. The state machines reduced abandonment and surfaced failure visibly. The UI removed friction at the point of first contact. The conversion strategy applied to Cotter's 4 inventions in sequence. None of those were technical decisions made in isolation. What's next? Well, we have post-deployment measurement using regs validated resistance to change scale. Adoption rates, reduced shadow IT incidents, and resistance scores together would show whether the system actually changed behavior, not just whether it was deployed. Chatterjee and colleagues framed the broader point well: information technology can support better organizational behavior. That is what this project attempted to demonstrate. This is the course outcome in practical form. Analyzing a system also means analyzing an organization. Thank you.